Hello friends, I'm giving this address to the aspirants of medical entrance exams, students who are primarily focusing to exam like NEET, AIIMS and other medical entrance exams. Since I teach physics and I've been involved with the teaching of these kind of exams for the past 40 years, I'm too pleased to share my experiences about these exams and the strategy that you can prepare, that you can have for preparation of these kind of exams. First of all, the importance of these exams. As you all know, that this is a highly competitive exam, and every student who is trying to be admitted in one of the top medical colleges, he or she has to score very high grade in this exam. Something like we are aiming at 600 plus, because there will be about 10 lakh students who will be appearing every year, and out of that, the top students, I can say around 50,000 who will be admitted in the top medical colleges. So, the competition is very severe. Let me make that point very clear to you. If you have been a good student of physics for your class 11 and your class 12, then you should not find this exam as difficult. But it is a different exam. It is very different than what you have been already used to learning, the way you have been used to learning physics. I would like to make that point clear, that as far as physics is concerned, I'll bracket it in two categories. One is the academic exam, that's what I call academic physics, and the other is applied physics. Now, in the board level exam, your school class 11th exam or the 12th board exams, you have been going through all this syllabus. Well, understand the basic difference between the academic physics and the applied physics. The type of examination, like the board exam or your school exams, where you have been learning all these chapters in physics, well, you have been emphasizing more on the academic part. That is, knowing the concepts, knowing the laws, the principles, the definitions, the derivations, the explanations of certain apparatuses, theory of certain instruments, well, doing practicals in the lab. This is what I term as academic exam, the academic kind of learning physics. But in exam like NEET, the syllabus remains the same, the content remains the same, both for 11th and 12th class syllabus, but all the questions are applied. So, the emphasis is more on not simply knowing the concept, but understanding the concept, understanding the depth of the concept, each and every concept, and then how to use these concepts to apply problems in an analytical manner or even the qualitative aspect. For example, I take, let's say, Ohm's law. Now this is one concept, V equal to IR, that everybody knows. But then, the entire electrical technology is based on the application of Ohm's law. Similarly, if I say Newton's law, especially the second law of motion, F equal to ma, that this concept everybody knows. The unbalanced force produces acceleration. The unbalanced force F produces an acceleration A on a body of mass m. But now, to apply this concept, I can say all the classical motions are, the authority of all those motions is the Newton law. Whether it is motion in a straight line, or in projectile motion, or circular motion, or rotatory motion, or simple harmonic motion, everywhere you use the Newton laws because they deal with motions. And the authority of all that motion is Newton law. So simply knowing the concept is not enough. How do you apply it? Now when I use the depth of knowing the concept, then I also should emphasize on the concept that you could be knowing, but perhaps you may be having a misconception. So you should be very clear in that. I'll give you a very simple example. An ordinary student may just think that friction opposes motion. But, well, that is not true, because in the kind of applied problems that you face, you may not have a simple problem where a body is sliding in a particular direction, and so you just say that the kinetic friction is acting opposite. So you should understand this very well, that as far as sliding friction is concerned, the correct concept is that it opposes the relative motion of the point of contact. It opposes the relative motion of point of contact. So for example, if there is a body, now friction would act between solid surfaces in contact. So if between the surfaces there is, if a body which is sort of moving on another surface, I say moving. Now moving could be sliding, could be walking also is moving. There is also rolling. But in all these cases, all that you have to be very clear that what is the point of contact, what is its velocity, and on the surface on which it is moving, what is its velocity, and if there is a relative motion, that is the velocity of the body related to the surface is different, then friction would oppose the relative motion. So friction opposes motion is not correct, but friction opposes the relative motion is the correct concept. So like this. So this way, what I'm trying to emphasize is that when you do a concept, when you learn a concept, this of course you have to do it. This you have been doing it in your school level, in all the school level study, in your board exams and so on. But then do not make a mistake in not understanding it properly or using it or learning it in a superfluous manner. You should be very clear about the depth of that particular concept. I'll give you another very simple example. Let's say, if I ask you a simple question, that if a capacitor plate, between the two capacitor plates, one plate has charge Q and the other has minus Q, and the PD between them is, let's say, V, the potential difference between them is V, and I ask you, what is the capacitance of the system? Then normally a student would say, it is Q upon V, C equal to Q upon V. Fine, nothing wrong in that. But the next question that I ask, that what is Q? That many students will jump at the answer, well, Q is the charge stored and V is the PD between them. And that looks on face value the correct answer. What is the unit of C? Well, they say Coulomb upon volt. But then, just have a little deeper thought. One plate has Q and the other has minus Q. And the capacitor is a system consisting of two plates. So one is Q, the other is minus Q. So the net charge stored in the capacitor is zero. The capacitor as a system has zero charge, and that will always be. And I'm talking of the inner faces. So then my next question would come, what does capacitor store? Certainly it doesn't store charge. When the net charge on it is zero, you are convinced now. So what does it store? Then the answer is that capacitor stores electrostatic potential energy within the electric field, within its control volume. Now, what's that control volume? Control volume is, for example, in a parallel plate capacitor, it will be face area A, D. So, you think of a box of volume A into D. Now, within this A into D, this plate has plus Q, this has minus Q. So, the electric field is from positive plate to the negative plate. Between them there is a PD, and if there is PD and the distance between them is D, then, well, there is a potential gradient. Potential gradient is electric field. So I can say that in a charged capacitor, there is an electric field from higher potential plate to the lower potential plate. And within this electric field, now we all know that within every field there is a stored potential energy. So in the electric field, within the control volume. Now that's a new word maybe you are listening to. So in a parallel plate capacitor, for me the control volume is face area A into D. That's the volume of that sort of box in which the field is there, electric field is there, and within that the energy is stored, potential energy is stored. But it could be Q square by 2C, it could be half CD square, or it could be half QB, where B is the PD. And like that you can get it. Now you know the correct concept of the capacitance. Now let me take you a little further. I ask you the question, if you earth one of the plates, then what would happen? Many students would immediately jump at the answer. By earthing, the capacitance would increase. How? The capacitance would increase by earthing one of the plates. How? Give it a deeper thought. If I ask you what is the capacitance of a parallel plate capacitor, I think any student can answer. So it is epsilon naught A by D. Or if it is a concentric sphere, then 4 pi epsilon naught R1 R2 upon R2 minus R1. Or if it is a case of concentric cylindrical capacitor, then it is 2 pi epsilon naught L upon Ln R2 by R1. Very fine. Where is earthing to do? What is earthing to do in that? Nothing. It only depends upon the dimensions. Like for a parallel plate capacitor, the face area A, the distance D between the plates, and the permittivity. Now if it is free space, I use epsilon naught. If there is a dielectric within it, completely filling the plates, well then I use the permittivity of that insulating medium. It will be epsilon naught A by D or epsilon A by D. So what is the role of earthing then? The role of earthing would simply be that if I give any amount of charge Q1 to one plate and any other charge, say Q2, not necessarily minus, then the bound faces, the inner faces of the capacitor will have equal and opposite charge. And if I earth one of the plates, then the outer faces of both the plates will have 0 charge, and the net charge Q by Gauss's law that we can work out will come on this face and will come on this face minus of that, and then the entire field gets confined within the plates, in the region between the plates, in the control volume of the capacitor. For the parallel plate capacitor, I take it as A into D, and for a spherical capacitor, I take the control volume as 4 by 3 pi R2 cube minus 4 by 3 pi R1 cube. Within that is what becomes the control volume. So this is what I'm trying to say, that you should be very clear about the concept, the understanding of the concept, because then you don't make a mistake. Then you don't make a mistake in applying the concepts to problems. So we talked about knowing the concepts, we talked about understanding the depth of the concepts, and I've also talked about, by taking these small examples, simple examples, that not to think of the misconcept as a concept and then solve the problem, because then you get trouble in solving problems of physics. And let me tell you, for the NEET exam, all the questions are going to be applied. And the applied question also I'll classify in two categories. One will be the qualitative application, where we may not use that much of mathematics, but nevertheless, the right concepts and the depth of the concepts will be tested. And only then the student can arrive at the correct qualitative answer. And the other is, of course, the analytical application, where there will be straight away problems dealing with formulas, and then you work out the answer. Now, in the analytical concept also, I would like to say something to you. Many of the students, especially the medical aspirants, they think, because in most of the places where you get key points and you get the sort of a list of formulae, and they think that if I mug up all the formulae, then the problem is solved. No, sorry, very sorry. Because knowing the formula, yes, but then once again, that formula is according to a particular concept. according to the particular concept. So you should be very careful how to apply a particular formula for a particular kind of problem. Otherwise, you will arrive at wrong answer. And if you start doing hit and try, if your conceptual depth is weak, then that is what happens. The student starts struggling. Then he starts doing hit and try. Hit and try means he will rely upon chance to get an answer. And now this is a professional exam. If you arrive at a wrong answer, then not only if the right answer fetches you 4 marks, but a wrong answer, a wrong choice mark will not only give you 0, but there will be a negative marking as well. So overall your percentile will come down and your ranking will just go down. So this is what I'm trying to emphasize on. I give you another very simple example, which many of the students while teaching physics, I've seen that some of the very good students also make that mistake. A block is lying on a table. And I ask, what are the forces acting on it? He'll say mg down and normal contact up. Very true. Are they equal and opposite? Yes, sir. Are they action-reaction pair? Yes, sir. They jump at the answer. Yes, sir. Because mg and n are equal and opposite, so they are action-reaction pair. Now that is not how it is. Just give it a deeper thought. The same block, if it is kept on an inclined plane, the same block, if it is kept on an inclined plane, then you all know that then n becomes equal to mg cos theta, because you crack mg into 2 components, one along the plane and one perpendicular to plane. And perpendicular to plane, if the block is in equilibrium, then n is counterbalanced by mg cos theta. So n becomes equal to mg cos theta. So if n and mg are action-reaction pair, so you go wrong. Because n now is mg cos theta. That is one. Go still deeper. What is the root cause of mg? Answer. The correct answer is, it is by virtue of the force of gravity, the gravitational force acting on m due to Earth. So it is gravitational in nature. Mass-mass interaction. And what is the origin of n? N is a contact force. It is a component of the contact force. The normal component of the contact force, and that is molecular, the molecules of the block, material of the block, and the molecules of the surface of the block being in contact. And molecular interaction is electromagnetic in nature. The n that I'm using, the normal surface contact, the normal component of the contact force is a normal component of the contact force. So its nature also should be electromagnetic. So how can two forces, one electromagnetic in nature and the other gravitational in nature, can be an action-reaction pair? Another interesting thing. Newton's third law tells you, if I ask this question, everybody will jump at it. Oh, sir, to every action there is equal and opposite reaction. Everybody knows that. Then I say no. Listen carefully. To every action, there is equal and opposite reaction, and action and reaction should act on different bodies. Now here, you are drawing the free body diagram on M. mg down due to Earth, n normally up, the normal component of the contact force by the surface. Both the forces are acting on M. How can action-reaction act on the same body? Impossible. You are going to swim. So what do? You and water, 2 bodies. You push the water backward and the water pushes you forward. You apply action, force on the water backward, and the water pushes you, apply a force equal and opposite to you in forward direction, you move forward. You want to go fast, you push the water hard, and the water will also equally push you harder and make you go further. Same thing is in walking. So while you are walking, what exactly you do? You apply a force on the ground like this, and by virtue of friction, you are able to take the grip. Your foot, your shoe does not slide. By virtue of friction between your shoe and the surface, you are able to take the grip. And you apply it like this while walking, like this. You push the ground downward like this, and the ground pushes you equivalent action, reaction like this. It's two compos. The normal compo balances your mg, and the tangential compo, that is static friction. So while you are walking, you are not sliding. By virtue of friction, you are able to take the grip. You push the ground backward, the ground pushes you forward, but the point of contact of the shoe with the surface remains at rest. Remains at rest. That means the friction acting on you, on your shoe, that is you, because you are taken as one body, one point, is forward. And it is the static
friction that is responsible for your forward acceleration. The static friction divided by mass will give you the acceleration. Harder you push the ground, जितनी जोर से तुमको आगे जाना है, उतनी जोर से ग्राउंड को पीछे धक्का मारना है, और ग्राउंड उतने ही जोर से तुम्हें धक्का इसी एंगल पे उल्टा मारेगा. आपने ऐसे लगाया, उसने ऐसा लगाया, इक्वल एंड ऑपोजिट, और उसके दो कंपो. नाउ दिस इज द कांटेक्ट फोर्स ऑफ द ग्राउंड ऑन यू. द कांटेक्ट फोर्स ऑफ ग्राउंड ऑन यू, द रिएक्शन ऑफ द ग्राउंड ऑन यू. Its normal compo, that is N, and its tangential compo, that is static friction. Now you are walking, you are running, but the friction on your foot is static, and it is in the direction of the motion, not opposite. But if you go by the wrong concept that friction opposes motion, तो फिर तो तुम उसको पीछे लगा दोगे. Now mg down and up, and friction is पीछे, backward. How are you? Who is propelling you forward? How are you going forward? That violates the whole motion. The whole idea is violated. Otherwise here N is balancing mg, static friction forward, static friction divided by mass gives you your acceleration. And now that is why different people will have different acceleration depending upon with what strength they are pushing the ground. So this is, I talked about something on the concept and the misconcept, and the story can go on. Believe me, in almost all the chapters, with my experience, I have seen even the very good students making this mistake of knowing thinking of misconcepts as the correct concepts, and then struggling. They keep struggling with the problem. So what I am trying to emphasize here is that do not jump at solving the problems unless you have really understood the concepts, you have understood the depth of the concepts, and you know the difference between the concept and the misconcept. So this was about the conceptual learning. This is what I say, understanding of the concepts. Let me now move forward regarding, because this type of exams, the time management, because there will be around, say in physics, 45 questions. The whole paper, well, you have 45, 45, 45, 45. That's 180 questions, and to be answered in 3 hours. So physics is one part that should be more time consuming. So you can save up your time in the because in the biology there will be some questions. Now I don't do biology, but then that's what I've learned from students and from my other colleagues teaching, that there are many questions which are informative. Now informative, you don't have to apply you know it or you don't know it. So if you know it, well, in 1 second you can answer. Same thing in physics, rarely you will find a question that will be informative. It will be conceptual application. Now conceptual application, it could be a qualitative explanation, or it could be the quantitative. Quantitative is the numerical, that's what I mean, where you use mathematics and formulae and so on. So that is it. So talking about the exam and the difference between the physics and the conceptual, the applications, now we have now also to think of time, because in any case, if you want to be among the top rankers, and our top rankers mean you are targeting something like 650 plus out of 720, then the decisive is going to be physics, because with biology, with a lot of hard work, and to some extent in chemistry also, if you are very good at mechanism with a good hard work, you can come up. But in physics, your hard work will be of no use if you are failing to understand the depth of the concepts properly. Now comes the time factor. Sure, I would like to speak few words on that. I'll give you a very simple example. Let us say I've got an electrical circuit, and this electrical circuit, there are 2 loops. I'm not even talking about the 3 loops, because more number of loops will become quite a subjective problem, which normally cannot be asked in an examination, NEET or AIIMS and so on. I'm talking of the single MCQ type, which are normally asked in the NEET exam. So if it's a 2-loop problem, then you can solve it by using Kirchhoff rule. But you must have the standard technique of converting that single loop into a single loop, because then you can solve or analyze that circuit. When I say analyze that circuit, it could be finding the current in the circuit, it could be finding the loss volt or gain volt of the cell, it could be finding, let's say, the TPD, the terminal potential difference of cell, it could be finding the PD between 2 points in the circuit. But for all that, the first and the foremost thing, you'll have to find the current. So current in both the loops. So if you use Kirchhoff rule, which you know very well, that could be at the board level. It's a 5-mark question where they ask you to state Kirchhoff rule, and then there is an application. Then you are obliged to solve that problem using Kirchhoff rule. But here you can convert that into a single loop by converting the 2 cell into a single cell. Now you should know the formula, how to, when the cells are connected in series or anti-series or parallel or anti-parallel, how to convert it into a single cell. Now here, because in this lecture I am not teaching you the topic, so I am just giving you food for thought. So think of the effective cell method, and then you can solve out the effective or the current, and then whatever the current is asked in a particular resistor or the external resistor, you can then solve the circuit. You can analyze the circuit and then you can solve whatever has been asked. There are a lot of questions which are asked on effective resistance of a network. Now be careful here. To find the effective resistance of a resistor network, and then you can shift on to capacitor network, you must know the cell points. To find the effective resistance, it has to be between 2 points. Now between 2 points, now there are so many standard methods by which a very complicated network can be easily solved. It may look, when you look at that complicated network, you may find 3 or 4 loops. My goodness, if you start applying Kirchhoff rules and all, then you will take at least a very big time to solve that problem. Now that will be horrible, because if you spend 15 to 20 minutes in solving a problem, better leave that problem. Because in order to gain 4 marks, even if you arrive at the right answer, you have already spent 50, and 1 minute a question, that would mean you have already lost at least 30-40 marks. Gone. The rank is gone. So you must have quicker method. Now wherever you are learning, or the very senior competent teachers, they teach you all those techniques. Now there are techniques, and then you should have that acumen, that which particular technique to use to solve that particular network. It's just like a doctor. He has all the theoretical background and all with his experience, but then when there is an emergency case, then he knows that what particular procedure to adopt to help the patient in the quicker possible time, in the quickest possible time. So same thing is here, it's the same mentality. You may solve the problem, but if you have spent a lot of time doing that, then that also is going to make you lose a lot of marks and lose out on ranks. Like, for example, in the network. Now I will not be teaching you the networks here, because that is, in this talk, that's not the purpose. I'm not teaching you any topic or techniques or whatever. I'm just telling you the strategy of preparing for the exam. So what you should do, for example, lifting the node is one technique, reduction method, second technique, Symmetry about the cell axis, third. Symmetry about the perpendicular bisector of the cell axis, another. Delta to star, another. Star to delta, another. So like that I have spoken 5 or 6 different techniques, and in all these techniques you can use whichever you feel. Now you may ask me now, so how will I choose which is the best? That's, I tell you, that is by your acumen, by your expertise, the way you have learned, and the more and more you practice, better it is, the better you will be. So that is about the quicker methods. For example, in the problems of mechanics, and whenever you have a body whose motion is being analyzed with respect to a non-inertial frame, that is what we call an accelerated frame, then by the use of pseudo-force concept, you can straight away get the relative acceleration. You can straight away get the relative acceleration of that body with respect to the non-inertial frame. So then the pseudo-force technique will be very handy. But if it does not require, then you can of course even solve that problem using applying the Newton laws with respect to the inertial frame, and you can get the absolute acceleration as well of that body. So what I am trying to say is that as a smart student, you should know all these techniques, and any good faculty of physics for these applied exams normally would teach you up all these techniques, and then these become your tools, तुम्हारे हथियार हैं ये, to crack the problems, and to crack the problems in the quickest time. The early, the better. As much time you can save is more marks earned, So emphasize on learning the quicker method techniques to crack the problem. This is another strategy that you should have. I would also like to know, now many students would like to know about the different books, the different materials. Let me advise you one thing. There is no dearth of books in the market. Please do not run after many books. You have a very limited time. Exam preparation, even your preparation time is very, very limited. Therefore, don't run, and don't also forget that reading many books would also confuse you up. So there are some standard books. So wherever you are learning and you have got a senior faculty and you are used to that faculty, you like his or her style of teaching, the methods and all that, and you feel very comfortable, then of course follow his advice. Just like as a patient, you have to have trust on your doctor. Similarly, if you have a good faculty teaching you, I am talking only about physics, then trust your faculty, trust your teacher, what he tells you. Okay, since I am guiding you right now, helping you the strategy, I'll tell you few books for NEET, maybe 2 or 3, that'll be good enough. Number 1, knowing the concepts. To know the concepts, you can use H.C. Verma. उसके किताब का देखो टाइटल ही है Concepts of Physics. So okay, to learn the concepts, to know the concepts, you can use H.C. Verma. NCERT, good, but then reading of NCERT is a little cumbersome. Students don't appreciate it. Now I am not criticizing NCERT. You can use NCERT book for solving the problems. Unki exercise, unki exemplar problems, very good. You can do that. But reading from NCERT will not be very encouraging to you. So for that, you can knowing to know the concepts, fine. H.C. Verma book is good. Number 1. Second book I advise you that you should have. Now this is, I am using the word should. H.C. Verma concept सीखने के लिए concepts को अब जिसको आप key points और ये सब for the NEET exam, universal self scorer. उसके 2 volumes हैं. Volume 1 takes care of the 11th syllabus and volume 2 takes care of the 12th syllabus. सारे आपके 29-30 chapter पूरे, both these volumes will cover. The beauty for that book, why I appreciate that book, number 1, it is well printed. Number 2, he claims it is errorless. देखो कुछ errors तो सब जगह होता है, लेकिन अगर generally from my experience I have seen there are not many mistakes. So it is more or less I can say by all probability it is errorless. उसके answers, the answer key and solutions you can trust. You can trust. Well, I can also trust. 100% कोई perfect नहीं होता. So I cannot say that this book also is 100% perfect. The another beauty of that book, what I appreciate is that every particular unit or every chapter that he has taken, he has broken it up into subtopics. For example, like electrostat, he'll talk about charge, about electric field due to point charge, electric field due to charge bodies, potential energy, dipole, Gauss's law and its applications. Beautiful. So already that subdivision is done, and the beauty is that in all those subdivisions, the past questions that have been asked on that particular subtopic, he has already assembled that for you. So if you are, for example, revising on dipole, let's say you know the concept about dipole, you know about all the physics of the dipole, कैसे उसकी field होती है, axis पे होती है, equator पे होती है, या किसी point पर होती है, या उसका torque लगता है in an external electric field. All those concepts you have already done. You have done it in your normal 12th class also. You have learned it from the H.C. Verma book also. You look at the exercises of the NCERT also. Then all those questions that have already come in AIIMS, in NEET, in Purane wala AIPMT, in AFMC, he has assembled all these questions for you. Then he gives you a chapter on critical thinking. So this is for the higher ranking student aspiring for the top ranks. So once you have understood all the concepts, you have started applying, so this will give you sufficient practice. और अगर आपका कुछ नहीं भी हो रहा, तो you have got the answer and you got a solution as well. हाँ, solution में भी कुछ समझ नहीं आ रहा, there is possibility, there are some complicated questions, उसके solution भी tedious है, वो नहीं समझ आ रहा, तो उसके लिए आपका faculty है. Then you of course take, but remember, the maximum you have to struggle yourself. A good faculty will teach you the concept, a good faculty will teach you how to apply the concept, a good faculty will be able to tell you what are the concepts and what is the misconcept, the techniques of solving problem. Now that is the job of a good faculty. He will do that for you. But then practice तो तुमको ही करना है. That faculty is not going to sit for you for your exam. वो तो तुमको ही करना है. Practice तो तुमको ही करना है. Perspiration has to be yours. मेहनत तो आपको ही करना है. तो वो प्रैक्टिस के लिए आपको वो सब मिल जाएगा. और जो प्रैक्टिस भी आप कर रहे हो वो सिस्टमेटाइज प्रैक्टिस है. दैट इज गुड. सो इन नटशेल आपके पास एनसीईआरटी तो है ही, एचसी वर्मा वॉल्यूम 1 वॉल्यूम 2 फॉर लर्निंग द कॉन्सेप्ट्स, देन प्रैक्टिसिंग सब टॉपिक वाइज क्वेश्चन, यूएसआर, और कोई जाने की जरूरत नहीं है. एंड देन ऑफ कोर्स यू कैन टेक द यूजुअल टेस्ट पेपर्स. अगर कहीं आपने ऑलरेडी ज्वाइन किया हुआ है तो वहां पे आपको उसी इंस्टीट्यूट में या उस कोचिंग संस्थान में आपके सब वो प्रैक्टिस पेपर्स तो होते ही हैं, तो वो तो आप करते ही हो, वो करो. और फिर फाइनल मॉक पेपर्स, द मोर एंड मोर मॉक पेपर. और उसमें कोई ज्यादा भागने की जरूरत नहीं है. जस्ट पिक अप द पास्ट नीट पेपर्स, द पास्ट AIPMT पेपर्स, द पास्ट AIIMS पेपर्स एंड प्रैक्टिस देम. More and more, as they say, practice makes a person perfect. So more and more practice, better understanding of the concepts, application of the concept, knowing the difference between the concept and the misconceptions involved, the techniques of solving the problems. In nutshell, you will be a cracking student, and I wish you all the best. All good students can then aspire for top ranks in the NEET, in AIIMS, and wish you the very best. You become top doctors for our nation. Thank you.